uncertainty. Uncertainty, okay? So uncertainty in the value is that plus or minus value, right? And two-type uncertainty, and I hope you guys have some exposure to it. There's absolute uncertainty, right? And there's relative uncertainty. Okay? Absolute uncertainty are the value that plus or minus. So when you were doing the rates of reaction, you were calculating the volume, right? And the volume has plus or minus 0.5 milliliter. So that's your absolute uncertainty for volume, right? And for your, when you're measuring time, it was plus or minus 1 second, yeah? So that's your absolute uncertainty for volume and time. Yeah? Now relative uncertainty is the percentage of how much does that matter to your measurement. So let's say you were measuring a volume of 5 milliliter, then what is your relative uncertainty for volume? Well, it's 0.5 divided by 5 multiplied by 100%. So that's 10%, right? So your relative uncertainty for volume is 10%. Seems like pretty big. If you increase the volume that you measure, then your relative uncertainty will get smaller. So absolute uncertainty doesn't change as well as absolute. Relative uncertainty change depending on the quantity that you're measuring. All right, might as well do time. So let's say if you were measuring 10 seconds, or let's do 20 seconds, change it a bit. 20 seconds, then your relative uncertainty for time is 1 divided by 20 multiplied by 100%, so you get 5%. Yeah? All right. Once you get that, then in a lab report, there is, at least for a lab report that you do experiment, not the secondary data, there's a section called Propagation of Arrow, and you have to have that section. I think there was one student in the class did it from physics, because the way he wrote it, looks very physicsy. I can't remember which one it is, who it is. But anyway, propagation of error is propagation of error is when you calculate some number based on the value that you get. What is your final uncertainty? And there's two different types of propagation of error. So if you're adding two numbers, or you are a second case, you could be adding or subtracting, you could be adding or subtracting two numbers. Subtracting. You could be dividing or multiplying, right? Multiply or divide. Okay? So that you add or subtract or multiply or divide. When you add or subtract, the rule is that you are adding. For uncertainty, you are going to add the absolute uncertainty. Final uncertainty is adding absolute uncertainty. Okay? What does that mean? So let's say here you have the example we did, an inverted cylinder, not an artist. Yeah. So let's say you have an inverted cylinder, and your beginning measurement was 10 milliliter, and then after the reaction, your final was 30 milliliter, right? So how much volume have increased from 10 to 30? Well, the volume that you get is 30 minus 10, so that's 20 milliliter, right? What is the uncertainty for this 20 value? Well, this 30 milliliter has an absolute uncertainty of plus or minus 0.5, right? So it's 30 plus or minus 0.5 is this reading. This 10 is also plus or minus 0.5. So then the reading, the final reading, when you're subtracting the two number, is you have to add the absolute uncertainty. So the uncertainty for this 20 milliliter value is 0.5 plus 0.5. So it's 20 milliliter plus or minus 1 milliliter. Does that make sense? Because each of these have that uncertainty, so two of them together will be that much. So for the case where you're adding or subtracting two value, the final uncertainty is adding the two absolute uncertainty together. Yay? All right, when you multiply or divide, the situation is a little bit more complicated. So for example, if you're measuring a rate of the reaction, so the rate of the reaction is measured by the volume over time, right? So taking this example, the volume that you measure was, let's say, 5 milliliter of gas, and the time that you measure was 20 seconds. So your rate is 5 divided by 20, so that's 1/4, so 0.25. 0.25 milliliter per second. That is your rate, right? So what is the uncertainty for that 0.25 milliliter per second? Well, you got to propagate it, and the rule is whenever you multiply or divide, you have to add together. You have to add together the relative uncertainty. And then convert it back to absolute uncertainty. Keeping one decimal. 1 decimal. Okay, or what does that even mean? Well, it means that here's your rate. The uncertainty for this rate will have to be whatever percentage uncertainty for this guy. So 5 milliliter have a relative uncertainty of 10% here, right? So 10% uncertainty for this value. And then this 20 second have an uncertainty of 5% here. So that's 5%. So this 0.25 milliliter per second is going to have an uncertainty of plus or minus 10 plus 5, 15%. You with me? And then now, what is that 15% means in terms of milliliter per second? You have to convert that back into this. So 15% of 0.25 is 0.0375, and then you have to round it up to 1 decimal. Keep 1 decimal, okay? So that would be 0.04. Okay, so this final value is 0.25 milliliter plus or minus 0.04 milliliter per second. So that's your absolute uncertainty. Propagated from the value that you have. Physics kids, you guys use the formula, I think I saw you used it. Delta V over V plus delta T over T, right? Equal to the delta rate over R. That's the same idea. This is this. Right? This is this. This is your relative uncertainty. You're adding them together to get the absolute uncertainty. So it's the same idea. Yeah? Okay, that's it. Thank you, Dan.